So there was an error with question 12. There was an error with question 12, an error with the wording. So I said that the work done on a electron, the correct wording was work done on a charged object. So if you got question 12 wrong, I gave you 8 points for it, right? So if you got it wrong, I gave you 8 extra points. If you didn't get it, if you got it right, I didn't give you any extra points because you got it right. All right. Let's go over the questions now. If I recall, we were on question 7. Am I right or am I wrong? We were on question 7. We were on question 7. Question 7. Question 7. So question 7, what are my notes? Question 7, what are my notes? I'm glad that. Hello? Hello? So if no one answered this, you're all getting 0 for classroom participation.
Wait, what was the question?
Just give me my notes for this problem.
FE is equal to 2.8 times 10 to the negative 9.
FE or E?
Oh, shoot. My bad. It's E.
Yeah, E. Okay. So E, you can't see, it's all blurry for you. Maybe it's my internet connection. Is it blurry for you guys? Is it blurry for you guys? You? Me? No?
It's a little
No.
blurry.
A little blurry. Hmm. What are the problems with using school internet? All right. Is this okay?
I guess, yeah.
You guess. Is that a yes? No. Like, how blurry is it? It's a bit blurry. It's probably because I'm streaming on my laptop and then I'm also trying to record the lesson too. No, if it's happening for multiple people, then it's probably either me, the school internet, or the fact that I'm streaming on a laptop and recording at the same time. Could be any one of those problems. Could be any one of those. So the electric field strength at point P, the electric field strength at point P, right, is 2.9 Oh, I'm gonna hate this. Electric field strength is 2.8 times 10 to the negative 9 newtons over coulombs. You have a proton, so you know that the charge of one proton is positive 1.6. And then you're asked to find what the electrostatic force is, what the magnitude is. And so the only formula involving electric field that you've learned thus far is this one. And you're solving for Fe, so you're going to multiply by Q on both sides. You get QE, so QE is equal to Fe. Then you just plug in your known, so you get Q is 1.6 times 10 to the negative 19. E is 2.8 times 10 to the negative 9. Is equal to Fe. So you multiply this, you get 4.5 times 10 to the negative 28 newtons. All right. That is that. Any questions? We learned that Fe is equal to EQ. Well, I mean, if you multiply by Q on both sides, then Fe is equal to EQ, yeah. Because you can just like reformat this equation, right? If this is this, then what you can do is just multiply by Q on both sides. I'll give you guys like a minute, 30 seconds. You know, if you want to copy this down, man, you can. Can or cannot, you know, up to you really. Okay, let's move on, guys. If you need me to hold it here, let me know. Let's move on. Also, this question, guys, you know how I like doing this. I love just going back and showing you guys which homework questions this was like. It was question 6. Pretty much the same exact question as 6. I just changed your knowns, and instead of an electron, I changed it to a proton. So that was that. So instead of an electron, I changed it to a proton. I changed the knowns, and it was essentially asking for the same exact unknown. It was basically question 6 on homework 6.3. Same thing. Let's move on. So you have two identically sized metal spheres, right? So A and B. And they possess an excess of of that many protons. Now, this is not a math question. They're asking you like, well, sphere A has a lot of protons, right? It has much more protons than electrons, right? It has an excess of amount of them. And sphere B is neutral, you know, sphere B is neutral. Sphere B is neutral. And then, which means it has an equal amount of electrons. Now, well, what would happen if you brought sphere A next to sphere B? Well, positive charges attract negative charges, right? So this positively charged object A is going to attract the electrons in object B. And so what's going to happen is that all the electrons are now going to bunch up to the side next to sphere A, right? Because it's attracting. the electrons are being attracted to the positively charged object. And so what happens is that this side, right, one side becomes negative and the other side becomes positively charged. Any questions about this logic here? Which means that your answer here is this one. That's your answer. This question,
Why did they show that the protons move?
they're not showing you the protons are moving, they're showing you the charge, right? They're showing you whether or not which side is negatively charged and which side is positively charged. But it's saying charge distribution right here. Saying charge distribution. I don't really go into this because in the end, students don't really need to know it, right? I do tell you that, I do remind you that protons don't move and that like one side does become negative though and the other side becomes positive. So that's what these diagrams mean. These diagrams aren't showing you the placement of the charges. They show you the charge distribution, the overall charge. So this is saying that one side is positive and the other side is negatively charged. The second choice right here is saying that both sides are positively charged, or rather the entire thing. Now, guys, this question, question 5 on your homework. The only thing I changed from your homework question, let me just make it a bit bigger. The only thing I changed from your homework question was that instead of saying you had an excess amount of electrons, which is what your homework question said, I changed this to an excess amount of protons. That's all I did. That's the only thing I changed. I didn't do anything else other than change one word. And so the answer becomes B instead. Number 10, this is 9, I think. This is 9? No, this is 9. Number 9. When wool is rubbed against a PVC pipe, the wool becomes positively charged. I don't know how many times I've said this in class. I'm not really sure, but I'm 100% sure that I've said protons don't move. Right? I think I've said this many times. Answer choice 3 and 4 are saying protons are moving. So if you remember this fact, you already eliminated 2 of the choices. So, which leads to your next question, well, how does something become positively charged? Well, for you to become positively charged, you must lose electrons. Because positively charged means you have more protons than electrons now. So if you're positively charged, you've lost electrons. So electrons are being lost by the wool and they go to the PVC pipe. This question was question 3. On homework 6.4, it was question 3. A glass rod, the only 2 things I changed, well, I changed a couple of things. Instead of a glass rod, which number 3 on your homework said, I changed it to wool. Instead of silk, I changed it to PVC pipe. The rest of the question is the same. This net positive charge accumulates because the glass rod, well, the wool in this case, right? Because I changed the wool, does what? Why does it become positively charged? Well, it becomes positively charged because it lost electrons. I changed the wording of the answer choice, right? The answer choices are worded differently, but they still say the same thing. Lose electrons. Transfer electrons from the wool to the PVC pipe. So they were the same question. Are there any questions about my explanation, your understanding about question number 9? Number 10. So you have an electroscope. It's made out of metal. So you have a knob, stem, leaves. And then it says the problem, you bring a negatively charged rod near the knob of the electroscope. And then you remove it. So what happens to the motion of the electrons? Now, I think, I'm not sure, I recall no, that's positive charge, positive charge, right? Whatever. Just like what's happening in this GIF right here, right? If you bring a negatively charged rod near a neutral object, what happens is that the electrons go to the other side, right? They get away. The electrons are being repelled by this negatively charged rod. So you're going to apply the same logic here. So let me just draw this so it's, let's draw one, let's draw this, let's draw this. So the electroscope is originally neutral, right? So you have a neutral, it's neutral throughout. But then you bring a negatively charged rod near the electroscope, and well, what's going to happen is that, well, the protons aren't going to move, right? Protons stay still. But the electrons are going to move down the electroscope, right? They're going to move down the electroscope. And what's going to happen is that, well, because now the bottom of the electroscope is negatively charged, well, they're going to repel, which leads to them repelling each other. Now, when you take the negatively charged rod away, right? When you take the negatively charged rod away now, the electrons go back to where they originally were. and they go back up top. Right? They go back to the original position. So the only correct choice here is the electrons go from the knob to the leaves and then back to the knob. And then they go back. Any questions about this problem? This question? This question? Was question 1 on homework 6.4. And instead, now question 1 on homework 6.4 said that this was a positively charged rod. They brought a positively charged rod near the electroscope. The question on your test, though, I changed it from a positively charged rod to a negatively charged rod. And that is the only thing I changed. And because I changed it to negatively charged rod, it would be answer choice D. Oh, man. Okay. Let's go on to number 10 now. So sphere A carries a charge of positive 2 coulombs. Actually, let me just do version A. I mean version 1. So version 1. Sphere A carries a charge of positive 2 coulombs. So Q1, positive 2 coulombs, or Q2, negative 8 coulombs. The spheres touch one another, right? So they touch one another. And basically you're adding up the charges. So Q1 plus Q2 is equal to, right? So you have plus 2 minus 8 gets you negative 6 coulombs. And then you split them, right? Then you separate them. And now what's the charges? Well, what you need to do is you need to divide this number by 2. Because you're splitting it up into 2 spheres. And so you get negative 3 coulombs. And so now the new charges on these objects is negative 3 coulombs. That's it. I'll give you guys 30 seconds to 30 seconds to a minute to copy down the work. Are there any questions about this? Okay. I'm not even going to compare this question to your homework questions because this was basically any homework question on 6.5. It was any one of those questions. That was what this question was. I'm disappointed that some students got question 11 wrong, because I don't know. If you were paying some attention, right, then you would have gotten it correct. I was just in general disappointed that people got 11 wrong. Number 12. Now there was an error in number 12, right? The error in number 12, well, I fixed it by now. I fixed the error already. But the error in number 12 was that instead of a charged object, I wrote electron. Now, if you're writing down your knowns, you would be confused. Because you would say, well, you do 80 joules of work. So you're writing down your work done. So you have 80 joules of work. And then you read electron. And then, well, then when you read electron, well, my charge of an electron is negative 1.6 times 10 to the negative 19. And then you would further read, well, the potential difference is 170 volts. So then you proceed to write 170 volts. And then the question says, what is the electric charge of an object? And then you're going to be like, well, Q is question mark. Well, how is Q question mark if I already gave you what Q was? Right? If I already gave you Q, then why are we trying to find Q? So this might have confused some people. It was worded incorrectly. Now, if you knew, right, well, you're solving for Q, you probably would have just thought to yourself, well, this is a mistake. So you would just went on with the formula, right? V is equal to W over Q. And you're solving for Q. So then you would just move on, right? You would just forget the fact that you have Q already, and then you would just solve for Q. So 170 is equal to 80 over Q, multiplied by Q on both sides. So then you get 170Q is equal to 80 divided by 170. And Q becomes 0.47. Or 4.7 times 10 to the negative 1 coulombs. Any questions about number 12? Any questions about number 12? I'll give you some time to copy down the answer. Whew. Could I do 6? Sure. This question was like one of the questions on 6.6. Number 6. This was number 6, right? Properly drawn electric fields. So one thing about electric fields is that I drew them for you, right? So electric fields must point a certain direction. Positive electric fields, right? If positive field lines emanate outward, right? They point outward from a positively charged object. And the electric fields around a negatively charged object, they point inward. Now, picture 1 represents an electric field, right? If you recall doing it, then A is positive and B is negative, right? Because you have arrows pointing from one to the other. If your arrows are coming out from one object, which is A, you're positive, and going inwards, it's B. So B is negative, which makes sense. So choice 1 looks fine. Choice 2, right? Choice 2, you see that the arrows are pointing inward, right? The arrows are pointing inward like this, which means that it's a negative charge. Now, if both of these are negative, right? Because they're repelling each other. And the arrows look fine. The arrows look fine, right? They're all pointing in one direction. So choice 2 looks fine as well. Choice 3. Now, choice 3 is odd. Choice 3 is odd. Choice 3 says that you have arrows pointing inward at the top, but then at the same time, you have arrows pointing outward. I don't think I've ever shown you an electric field that has arrows pointing inward and also arrows pointing outward from the same object. Same thing with B on the other side. You have arrows pointing inward and then arrows pointing outward. So that's not correct at all. That's impossible. You cannot have, we don't draw field lines like this. We don't draw field lines that point in 2 different directions coming from the same object. We don't do that. We don't do that. We draw it completely outward or completely inward. We don't do half and half. So the third one was drawn incorrectly. And choice 4 is just 2 positive charges, right? Because they're both repelling. Right? Did I answer your question? Is this okay? Is that okay? All right, cool. Guys, if there are no more questions, I'll see you guys tomorrow. See you guys tomorrow.